Today's lesson is lesson 50, and it's about polynomial equations, ordered pairs, and the coordinate plane. So it's kind of an interesting lesson, a little bit all over the place. So first let's talk about polynomial equations. We know what polynomials are. We've learned about those in the last few lessons. But a polynomial equation has an equal sign in it. That's what makes it an equation. So right now this is a polynomial with two terms, two different variables and two different terms. But if I put in, say, equals -3 in it, it now becomes a polynomial equation. And it has three different terms. It has two terms on this side and one term on this side. And we've seen equations like this. We've called them multivariable equations because they have more than one variable. So the first thing I'm going to do in this one, if I'm asked to solve for y, we've also learned how to do this. So if I want to solve for y, that means to get the y by itself and move the other stuff to the other side. So all I really need to do is move this -4x. And I can do that by adding 4x to both sides of the equal sign. The 4x is going to cancel from here, and I'm ending up with y equals positive 4x and a -3. So now that I've solved it for y, this is another polynomial equation. It's actually the same equation, it's just rearranged a little bit. And something that's interesting about an equation like this is there are an infinite number of solutions. There are an infinite solutions to this equation. For every x value solution, there's another corresponding y value solution. And so what we're going to do is we're going to just choose values of x and plug them into the equation and evaluate to get y. So for example, what happens if x is equal to 0? If I plug 0 in here, then I would have y equals 4 times 0 minus 3, which would just be a -3. So that's one solution. I could find another solution by choosing another value for x. So I could say, what is the value of, if x equals 1, what is the value of y? So I would do the same thing, plug in 1 for x, so I'd get 4 times 1 minus 3, which would be 1. And I can continue doing this all day long. I'll just do another negative one. I'll do, say, -2. What if I plug in -2 for my x value? 4 times -2, what would be the y value? That would be -8, -8 minus 3, which would be -11. And so these are just a few solutions. I could keep going if I wanted to, but it's just to show you that there are infinite solutions that satisfy this polynomial equation. All right, and one way that we can write these solutions, I just made this XY table of values. I just made this table. But another way to write these solutions would be using an ordered pair. So I know that we've learned about the coordinate plane in ordered pairs. So we could write this solution, x equals 0, and y equals -3 as an ordered pair, which means they go in parentheses separated by a comma. It's always the x value first and then the y value. I could also write this solution as an ordered pair, 1, 1. And then finally -2 and -11. Okay, so those are just some ordered pairs. We've learned about graphing before. We know how to graph points on the coordinate plane, but just for some extra practice, let's go ahead and graph some points. We're going to graph these solutions on this coordinate plane. So first I need to draw my axes. I've got my y-axis here. It's not very pretty, but you can see it. And then I've got my x-axis here. X is always the horizontal, y is always the vertical. So I can graph these solutions by just doing points on the coordinate plane. The first solution is 0, -3. So that means I don't move it all in the x direction, the horizontal direction, but I move -3 in the y direction, which would be down 3. So I can plot my point there. So I plotted this one. I can also plot 1, 1, 1 to the right for x and 1 up for y. And so I have this line. I can actually connect these 2 points with a line. I could graph -2, -11, but my graph isn't big enough to go as far as 11. So this is going to be my graph. If I connect these 2 points, and if I kept going, this isn't very pretty, but if I kept going, this is actually the graph of a line. And this line, all of the points that lie on this line are part of the infinite number of solutions for the original polynomial equation that we were starting with. So we're going to go more into detail in this on the next lesson, but for now, what you need to know is you need to know how to solve for y, which you've already learned. You need to know how to choose values of x and calculate the corresponding y values, and then you also need to know how to plot points on the coordinate plane. And then one more thing. We call x, the x value is always the independent variable. It's the one that we're choosing values for, or we're choosing values for x to find y, and then y is always the dependent variable. Because the value of y is dependent, it depends on what we choose for x. So this vocabulary is going to come in handy later on, but that's all that we have for this lesson. So thanks for watching.